Okay, so we're going to finish the last running test review for the final, which is going to be on polynomials. Uh, Polynomials take on basically three forms for us. Right now we have a type where you're asked to classify the polynomial in a couple of ways. So that's number 100 and 101. All I'm looking to do is write it in standard form. Tell what the degree is, the number of terms, the leading coefficient, and finally name it. All that's written on your review paper, so I'm not going to continue to rewrite it. I'm just going to do those steps for you here. So standard form would be to list it from biggest variable term down to the smallest. So this one would have an x squared, then a positive 3x, and a minus 5. The degree is the highest exponent. This is the second degree, otherwise known as quadratic. The number of terms, there are 1, 2, 3 of them. The leading coefficient is the number in front of the biggest exponent term. In this case, it's a 1. Understood one. And finally, the name would be a quadratic as its first name, the degree name. And then the number of terms also has a name. Since there are 3, this is a trinomial. So quadratic trinomial is that one. On the test, I might just shorten this to write it in standard form and tell me the name of it. All right, following the same pattern for number 101, this time the last term is the biggest, so negative 5x to the fifth, and then negative 4x to the fourth, plus 3x squared, plus 6x. This is a fifth degree, or known as quintic. It has 4 terms, and the number that's in front of the x to the fifth term is a negative 5. And finally, because there are 4 terms in the quintic, this is called a quintic quadrinomial. The second part of this is learning how to add and subtract polynomials. Really, I think you should already know how to do this. This is just simply combining like terms. So in this case, when there's a plus sign, you can basically forget about the parentheses entirely. You don't really need them at all. Just go with whatever sign is in front of the term. So I got 3x squared, and I got another 2x squared over there. That is 5x squared. Now I can kind of cancel those out. I got a 4x here, and I got a 9x here. That's 13x. I got an x to the third here. That's 8 of them. And then negative 3, that's 5x to the third. I noticed that that's a bigger exponent, so I'm actually going to skip a step so that I don't have to go back to do this. I'm going to write it right here, because I know it's bigger than this one. And then finally, I have some numbers, negative 5 and 20, that's positive 15. That would be my answer, and it's already written in standard form because I took that step to remember to put the big exponent first. Okay, in subtraction, which is basically the same idea, except that this negative sign here is sort of like distributing a negative to everything here. So essentially, you're going to change the sign of each term. So from what they are now, I'm going to correct this to make this a plus, this a minus, this a plus, a minus here, and a minus here. And that'll take care of this. Then we don't need the parentheses at all anymore. So now I'm just going to combine like terms again. I notice that the biggest one I have is x to the fifth. I've got positive 2 here and negative 3 here. That's negative x to the fifth. I've got an x to the third here and here. Negative 3, positive 5, that's positive 2x to the third. I've got x here, I've got an x squared right here. but nothing here, so it's just plus 6x squared. I got x here and x here, that's 4, and negative 10, that's negative 6x. And the last thing, the number is 10, and negative 12, that's negative 2. And again, because I chose to go down the line, starting with the biggest exponent, the answer is already in standard form. We're getting into a little bit of a tougher problem now. Now we're multiplying. The first kind is just a single term polynomial, also known as a monomial, times a really big one here, which is a quadrinomial. All you really do, though, is multiply this term times each one of the 4 inside here, and then we have to rewrite it in standard form. So we have 3 times 2, that's 6. X squared times x is x to the third. 6x to the third. I've got negative 15 and x to the 6th. I've got positive 9x squared. And finally, I've got negative 30 x to the 4th. So again, I'm going to write this in standard form, so I need this big term to go first. So it'll be negative 15 x to the 6th, then the negative 30 x to the 4th, then the 6x to the 3rd, and finally the 9x squared. That's your final answer to that one. Not much more work than the other one. It's just a little tricky when you're multiplying exponents. You actually add the exponent. When we do this one, it's the same principle, except I need to make sure that I take the 2x squared times everything over here and the 3 times everything over here. So taking 2x squared times this, I'm going to get 6x to the 4th. Then I'm going to get 4x to the 3rd for the next one. And then finally, just an 8x squared. And now I'm going to move to the 3. Multiplying that first one, I'm going to get 9x squared. Then I'm going to get 6x. And then finally 12. So I got to write it in standard form and combine like terms. The only like terms I see are the 8x and 9x squared. And if you look at it, they go right down the line in standard form. So combine that one thing. Eight of them plus 9 of them is 17. And this is the final answer. That's pretty much one of your harder kind of problems. We move into the last one, which are maybe the most difficult, but also, again, by comparison to some of the other problems we've done here, not nearly as bad as some of the old stuff. I think it's pretty obvious to see what makes number 106 a little more tricky than others. Is because you have x's and y's mixed in here. Most of the time, even multiplying it isn't that difficult. It's writing it in the correct format that makes it as difficult as possible. So let's start by taking the 3x squared times each one of these terms. So here I'm going to do 3 times 5, that's 15. X squared times x is x to the 3rd. And then I don't have a y to multiply the y squared, so it's just y squared. I'm going to keep up that pattern for the rest of it. I've got negative 6 for the number. I've got x to the 4th. And again, no y to multiply by, so I've just got a y left over. Here I got 9x to the 3rd. And finally, 12x squared. That was multiplying this times everything. I'm going to switch it up now and go with the 2y now, times each thing. This time I got 10, positive, 10x, y to the 3rd, negative 4x squared, y squared. I have 6xy, and finally 8y. So the last step is to combine like terms if there are any, and finally put it in standard form. If you look through this, I don't see any terms that have the exact same variables and exponents together. So we don't have any like terms to combine, which means our final answer is going to be 8 terms long, but we run into that once in a while. So let's just put it in standard format then, which starts with the biggest exponent. That's this one. No matter what, even though it's an x and not a y or whatever, it makes no difference. Only the biggest exponent goes first. Now we need something with a third. Okay, I have one here, and one here. Well, this one has the biggest second degree variable, which is a y squared, so I'm going to go with that one. Sometimes you can think of it as the most complicated looking one of the ones you're comparing. All right, this one, okay, this one doesn't have a variable at all other than the x third. There's no y. This one has a y to the third and an x with it, so that one's more complicated. It goes next. Okay, then we have the 9x to the third, the last of our third degree things. Let's look at x squared. Okay, here I have one with an x squared and a y squared, and this one has just an x squared. This one is clearly more complicated. So negative 4x squared y squared. Then I do plus 12x squared. This one is more complicated than this one. So 6xy. And finally, 8y. A really long answer, but not impossible to just take your time. Take a deep breath, go through it step by step. All right, we're on to the last problem. This one says to expand and then multiply. If you look at even this really complex one, our goal was to take one polynomial times another. In other words, no more than 2 polynomials multiplied together at the same time. But everybody, I think, in here can expand this one, and you know that it's going to be this. So that's 3 polynomials multiplied together. That's not what we want. We only want 2. So if you remember from your worksheets, this one was brought down, and these two were put together into a more complicated looking polynomial. But it takes us down from 3 to only 2. We do this via FOIL. So the first terms are x squared. Outside is negative 5x. And inside is also negative 5x, which is a total of negative 10x. And then last is negative 5 times negative 5, positive 25. So then our step now is to multiply it just like we would have done in this one. In fact, this one is actually easier to multiply. So let's do the x times each of the 3 terms. That'll be x to the third, negative 10x squared, and 25x. And now let's do the negative 5 times these things. So that's negative 5x squared, positive 50x, and negative 125. So we have to combine like terms and write it in standard form. I see only one x to the third. I have a negative 10x squared here and a negative 5x squared here. That's negative 15x squared. I have a 50x here. Finally, I have positive 25 here. Actually, looking back at this, I think I made a mistake in this step. It's a pretty easy fix, but this one was x times 25. That should be 25x, which will change the answer to this one just a little bit. I'm going to go back and erase something here. We're good up until this point. So with this positive 25x and positive 50x, we have positive 75x. And then the last number is negative 125. This is your final answer. So if you've gotten to this point, you have everything that you'll be tested on the final. We do have a quiz just on polynomials, which is just this material, tomorrow, that is Tuesday, May 24th. But the final on Friday, and anybody who is a senior who has their final on Wednesday. So again, this is probably the main material that'll be on the final, along with the quadratic work that we did, graphing some linear equations, and so on. But I think if you can follow these running test review packets and follow the solutions online here, you'll be able to have no trouble whatsoever on the final.